Look at the next question. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? See here, what is our function? Combined area of a circle and a square. When it is minimum, what are the length of wires after cutting to two pieces? Initially it was 28 meter. Okay, so 28 meter wire is cut into two pieces. So one piece is to be made into the circle and other piece is to be made into a square. Okay, so here let's suppose it is a wire. Okay, total its length is 28 meter and this wire is cut into two pieces. Suppose it is x meter. Okay, then what about this length? It is nothing but 28 minus x meter. Okay, then here it is said, see, one of the pieces is to be made into a square. Okay, suppose this x meter length or x meter length of wire is to be made into a square. Okay, or you can take circle, whatever. Okay, so and here I am supposing this x meter of length wire or x meter of this wire is made into a square and this 28 minus x meter wire is made into the circle. Okay, then now what is the perimeter of this square? See, what is the perimeter? Perimeter is nothing but total length of this square, right? See, what is the total length? See, this square is nothing but, see, it is made from this x meter length wire, right? Okay, so here its total length, that is its total length is nothing but the length of the wire, right? That is perimeter of this square is nothing but length of this wire. That is perimeter of this square is equal to x meter. So what is the perimeter? See, let us take S be the side. Okay, so what is the perimeter of the square formula? 4s, right? So 4s is equal to x meter, right? Because perimeter is nothing but total length of the square. Okay, see, what this square is nothing but this square is made from this wire, right, of length x meter. Okay, this wire of length x meter. So here its perimeter is equal to the length of the wire. Okay, therefore here perimeter of the square is 4s. If s is the side of the square, then 4s is the perimeter, right? So 4s is equal to x. So what is s? S is equal to x by 4. Okay, then after that, here what is the circumference of this circle? Circumference of a circle is nothing but its total length. Its total length. Okay, so here this circle is made from this wire of length 28 minus x meter, right? So therefore its circumference means total length, right? Total length of the circle, that is this circumference is equal to length of this wire, right? Therefore its circumference, suppose r is the radius, then what is the circumference formula? 2 pi r, right? Okay, so 2 pi r is equal to 28 minus x. Okay, then what is r? R is equal to 28 minus x divided by 2 pi. Then now here what is our function? Our function is, see, combined area of the square and the circle is minimum. Okay, so here we have to find the length of these wires when combined area of area, that is combined area means the sum of these areas. Okay, sum of area of square and circle. Okay, so when it is minimum, what are the length of these wires? Okay, so let's take A1, area of a square. Area of a square is nothing but, see, if S is the side of the square, then area is nothing but S square, right? Then S square is equal to, what is S? X by 4. So x square by 16. Okay. Then A2, that is area of circle. What is area of a circle? Area of the circle is pi r square, right? pi r square. So what is r? R is equal to 28 minus x divided by 2 pi. So 28 minus x pi into 28 minus x whole square divided by 4 pi square, right? Because r square. Okay. Then 4 pi square. Then here pi cancelled. So 28 minus x whole square divided by 4 pi. Okay. Now let's find combined area. Okay. Now after that we will find the derivative of this combined area. First derivative, second derivative. Okay. A1 plus A2. Okay. That is A is equal to A1 plus A2. Combined area, because here we have to find when the combined area of the square and the circle is minimum. What are the length of these wires, right? So here A is equal to A1 plus A2, that is x square by 16 plus 28 minus x whole square divided by 4 pi. Okay, then let's find dA by dx. Okay, dA by dx. Let's differentiate it with respect to x. So here x square, that is 2x divided by 16. 1 by 16 into derivative of x square. Derivative of x square is 2x. So 2x divided by 16 plus here 1 by 4 pi is constant. So 1 by 4 pi into derivative of 28 minus x whole square is 2 into 28 minus x into minus 1, right? That is equal to, here 2 cancelled, so x by 8 minus this minus, okay, plus into minus, so minus, then 2 cancelled, so here 28 minus x divided by 2 pi. Okay, then after that, okay, let's simplify this one, because here we have to find the value of x, right? So here it is 2 pi, it is 8, so 8 pi is the LCM. So here we have to multiply pi, so x pi minus here 4 into 28 minus x divided by 8 pi. Okay, then that is equal to here x pi minus 4 8s are 32, okay, 112 minus plus 4x divided by 8 pi. Okay, so dA by dx is equal to this one. See here, let's take x terms together. So x is common in these two terms. So let's take x outside. So we will get 4 plus pi, right? 4 plus pi into x minus 112 divided by 8 pi. Okay, then dA by dx is equal to 0 implies this one 4 plus pi into x is equal to 112. Okay, it is equal to 0, that means it will go to right side, so it will be 0. 4 plus pi into x minus 112, that is equal to 0. That means 4 plus pi into x is equal to 112. That means that implies x is equal to 112 divided by 4 plus pi. Okay, so here we have found value of x. Then we have to find second derivative, that is d square a by dx square. We should get d square a by dx square greater than 0, because minimum, right? So greater than 0 when x is equal to this one. Okay, let's find d square a by dx square. Okay, now let's find d square a by dx square. See, we have got dA by dx is equal to x by 8 minus 28 minus x divided by 2 pi. So d square a by dx square is equal to, that is derivative of x by 8 is 1 by 8 into derivative of x, that is 1 by 8, right? Minus here 1 by 2 pi is constant, derivative of 28 minus x is minus 1 divided by 2 pi, that is equal to 1 by 8 plus 1 by 2 pi. See, we have got a positive number, that is greater than 0. Okay, So here d square a by dx square is greater than 0 at any point. That is, here we can say d square a by dx square is greater than 0 at x is equal to 112 divided by 4 plus pi. Okay. So here we have got this function is minimum. Okay. At x is equal to 112 divided by 4 plus pi. So what is y? X is equal to this one. So not y. X is equal to means, see this length. Okay. This length is 112 divided by 4 plus pi. Okay. Then another length of another piece is, that is length of square piece is 112 divided by 4 plus pi meter. Okay. So length of one piece of wire is 112 divided by 4 plus pi, and length of circle piece, okay, length of circle piece is, that we have to find, that is 28 minus x. Okay. So 28 minus 112 divided by 4 plus pi, that is equal to 28, cross multiply 28 into 4 plus pi minus 112 divided by 4 plus pi, that is equal to 28 into 4 is, yes, that is same thing, 112. So 112 will be cancelled. So 28 pi divided by 4 plus pi. Okay. So here length of square piece is 112 divided by 4 plus pi. Length of a circle piece is 28 pi divided by 4 plus pi meter. Okay. The next question, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. Okay. So here it is our sphere and it is the cone which is inscribed in a sphere. So here let us take, let h be the height of the cone. Okay. Height, and r be the radius. Radius of the cone. Okay. Which is inscribed in a sphere. Okay. And it is given capital R is the radius of the sphere. Okay. So if it is the center of the circle, then it is capital R, radius of the sphere, and we have taken R be the radius of the cone. Okay. That is base of the cone. Okay. So radius of base of the cone. So it is R. It is R. Okay. Then okay. So what is this length? It is also R, right? Because radius of the sphere. Then, and we have taken h be the height of the cone. Okay. This height, that is this length is h. Okay. Then it is R, right? Total length from here to here, total length is h. Okay. Total height is h and it is R. So what about this one? It is nothing but R h minus R. Okay. Total height is h and this one R. So this length is nothing but h minus R. Okay. So here see, consider this right angle triangle. Okay. This right angle triangle, we can write here by Pythagoras theorem, r square is equal to small r square plus h minus r whole square. Okay. That is r square is equal to small r square. Okay. Consider this right angle triangle. By Pythagoras theorem, we can write the equation r square is equal to small r square plus h minus r whole square. H minus r whole square. Let's simplify this one. R square plus h minus r whole square, h square plus capital R square minus 2hr. Okay. So here we have got r square is equal to r square plus h square plus r square minus 2hr. That implies, see here r square cancelled. Then we have got r square plus h square minus 2hr, that is equal to 0. Okay. Okay. That implies here r square is equal to, take this one left side, right side. So it will be 2hr minus h square. Okay. 2hr minus h square. Then here what is our function? Here prove that the volume of the largest cone, okay, volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. So here what is our function? Our function is nothing but the volume of the cone. Okay, that means largest cone means when the volume of the cone is maximum. So here we have to prove, that is, see, radius r is, that is radius r means radius of the sphere, that is 8 by, that is, okay, volume. Okay, so volume of the cone, that is when the volume is maximum, volume of the cone is maximum, its volume is 8 by 27 into volume of the sphere. Okay, that we have to prove. Okay, so for that here our function is volume of the cone. Okay, so we have to prove this volume of the cone is maximum. Okay, then after that we will prove this one. So here let's write volume of the cone. Volume of the cone is 1 by 3 pi r square h. Okay, r is the radius, h is the height. Okay, now here we will substitute what is r square. Okay, so 1 by 3 into pi 2hr minus h square. Okay, into h, that is equal to 1 by 3 pi 2 h square, h into h, okay, h square r minus h cube. Okay, it is our v. Now let's find what is, as usual we will find the first derivative, then second derivative, right? So here we will find dv by dh. Okay, here differentiate it with respect to h, okay, with respect to height. Then dv by dh. Okay, dv by dh, that is here 1 by 3 pi is constant into here 4hr, 2r is constant. Okay, derivative of h square with respect to h is nothing but 2h. So 2r into 2h, that is 4hr. Okay, minus derivative of h cube is 3h square. It is dv by dh. Okay, then dv by dh is equal to 0. That implies, so what is the value of h, that we have to find. Okay, so here that means 1 by 3 pi into 4hr minus 3h square is equal to 0. That implies 4hr minus 3h square is equal to 0. That implies 4hr is equal to 3h square. That implies here h cancelled. So here 4r is equal to 3h. That implies h is equal to, take 3 here, so we will get 4r divided by 3. Okay, so we have got h is equal to 4r divided by 3. See, here we have to find the maximum volume of the cone, right? So that depending on height. Okay, so here we have taken the derivative of volume with respect to height. Okay, so here h is, we have got h is equal to 4r by 3, and we have to prove this volume is maximum. Okay, that means second derivative should be less than 0. Okay, second derivative should be less than 0 when h is equal to 4r by 3. Okay, now let's find d square v by dh square, second derivative of volume. Okay, so that is 1 by 3 pi into, here it is the dv by dr, so 4 into r, that is derivative of 4r is the constant, so 4r into derivative of h with respect to h is 1, so 4r. Okay, minus derivative of 3h square with respect to h is 3 into 2h, that is 6h. Okay, So here now let's substitute h is equal to 4r by 3. So what is d square v by dh square, that is equal to 1 by 3 when h is equal to 4r by 3, that is equal to 1 by 3 pi into 4r minus 6 into 4r divided by 3, that is equal to, see here 3 into 4, that is 12. So 12r minus 1 by 3 pi is here, 1 by 3 pi into 12r minus 24r, 6 into 4, 24, 24r, that is minus 12r divided by 3. See, here we have got minus, okay. So here r is positive, okay. So whatever values of r, here we will get minus itself, right. So the here second derivative, when h is equal to 4r by 3 is minus, that is less than 0, okay. That means this volume of the cone is maximum at h is equal to 4r by 3. Okay, this volume of the cone is maximum at h is equal to 4r by 3. Okay, now what is the volume of this cone? So when h is equal to 4r by 3, this volume is maximum. Okay, so what is the volume? See, here we have to prove that the volume of the cone is 8 by 27 of the volume of the sphere. Okay, so therefore here we have to write volume of the cone. Okay, so what is the volume of the cone? That is 1 by 3 pi r square h. See, here we will substitute h is equal to 4r by 3. Okay. Okay, here we have got d square v by dx square less than 0 at h is equal to 4r by 3. That means the volume of the cone is maximum when h is equal to 4r by 3. So here we have to prove volume of the cone is 8 by 27 of the volume of the sphere, right? So for that we have to find volume of the cone when h is equal to 4r by 3. Now let's substitute h is equal to 4r by 3. Okay. So volume of the cone is 1 by 3 pi r square h. 1 by 3 pi. See, what is r square? Here r square is, see, we have got it from the right angle triangle. Okay. That is r square is equal to 2hr. So here also we have to substitute what is h. H is nothing but 4r by 3 into r minus h square, that is 16r square divided by 9. Okay, into r square h. H is 4r by 3. Okay, because see here we have to prove volume of the cone is 8 by 27 of the volume of the sphere, right? See, volume of the sphere means that terms will be in capital R, because volume of the sphere, then capital R is the radius of the sphere, right? So here we have to convert this r square to capital R. Okay, small r to capital R. Okay, here we have to prove, see, it is the 8 by 27 of the volume of the sphere. Okay, so here we have substituted r square and h. Okay, that is equal to, here let's simplify this one, 1 by 3 pi into, here 8, okay, 2 into, okay, because yes, 1 by 3 pi into r square is this one, okay, 2 into h is 4r by 3 into r minus h square, h is 4r by 3, so its whole square, that is 16r square by 9 into this h, that is 4r by 3. Okay, then 1 by 3 pi, it is into, right? So 8r square divided by 3 minus 16r square divided by 9 into 4r divided by 3. That is equal to 1 by 3 pi into, here let's multiply this one, and first of all let's take LCM. So it will be 9 is the LCM, so we have to multiply 3 here. So it will be 24r square minus 16r square divided by 9 into 4r divided by 3. That is equal to 1 by 3 pi into, here see, 24 minus 16, that is 8r square divided by 9 into 4r by 3, 4r by 3. that is equal to here 1 by 3 pi into here 8 into 4 32 r cube divided by 27. Okay. So here we have to prove 8 by 27 of the volume of the sphere, right? So let's take 8 by 27 outside. So here 8 by 27, then here 1 by 3 pi into here we have taken 8 by 27. So here remaining 8 4s are 32. So 4r cube. 27 already taken outside. So here see 8 by 27, 4 by 3 pi r cube. See what is a 4 by 3 pi r cube? That is nothing but volume of the sphere when r is the radius of the sphere. Okay, 4 by 3 pi r cube is the volume of the sphere. So we have got that is volume of the cone, that is it is the volume of the cone, right? So volume of the cone is equal to 8 by 27 into 4 by 3, that is 8 by 27 into volume of the sphere when volume of the cone is maximum. Okay, that is the question. See, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. So here we have proved it. That is volume of the cone that is equal to 8 by 27 into volume of the sphere when the volume of the cone is maximum. Show that the right circular cone of least curved surface and given volume has an altitude equal to √2 times the radius of the base. So here we have to prove when the curved surface area of the cone is minimum, altitude equal to, that is altitude of cone that is equal to, that means height of the cone that is equal to √2 times radius of the base, means √2 into r. Okay, if h is the height of the cone and r is the radius of the cone, then okay, here we have to prove this curved surface area of the cone is minimum, right? So let's write, see volume is given, right? So we will write the volume of the, what is our function? Our function is nothing but curved surface area of the cone. Okay. So first of all, let's write volume. Volume is equal to 1 by 3 pi r square h. Okay. Volume of the cone is equal to 1 by 3 pi r square h. Okay. We have taken h is the height of the cone and r is the radius of the base of the cone. Okay. Then here what is h? H is equal to 3b divided by pi r square, right? Okay, then after that, see here our function is nothing but curved surface area, only curved surface area. Okay, surface area of the only curved space of the cone. Okay, that is surface area S is equal to pi r l. Okay, that is the formula. Curved surface area of the cone is pi r l. Okay, l is this length. Okay, so what is l? Here we can write, see it is a right angle triangle. So from the by the Pythagoras theorem we can write l square is equal to l square is equal to h square plus r square. So l is equal to root of h square plus r square. So let's substitute this l is equal to root of h square plus r square here. Okay, so s is equal to pi into r into root of h square plus r square. Okay, that is equal to, see here what is our function? Our function is, that is S, right? Surface area of the cone. Okay, curved surface area of the cone. So here what we have to we have to find the derivative of this one, right? This function, that is S. So here it is better to square it. Okay, we know that if S square is minimum, then S is also minimum. So let's take square on both sides. Okay, so that this square will be removed. Okay, so here let's take S square is equal to pi square r square. Okay, squaring on both sides. So h square plus r square. Okay, so that this square root will be removed. Okay, so here after that, see what is h square? We have to substitute. Okay, from this volume we have got h is equal to 3v by pi r square. Okay, now let's substitute before differentiating. So pi square r square into h square is 9v square. H is this one, so h square is 9v square divided by pi square r raised to 4. Okay, plus r square. Okay, then that is equal to, here let's multiply. So pi square, here pi square r square into 9v square divided by pi square r raised to 4 plus pi square r square into r square, that is r raised to 4. Okay, so here pi square cancelled, r square cancelled, so remaining, that is 9v square divided by here r square. Okay, r square plus pi square r raised to 4. Okay, now let's differentiate it. Okay, that is ds by dt, sorry, ds by dr. Okay, now here after that, because here we have to find the minimum surface area, right? We have to prove it is surface area is minimum. Okay, so for that we have to find the value of r also. Okay, so let's differentiate it, ds square by dr. It is the first derivative, not second derivative, ds square. Okay, we finding the, here we have to prove s square is minimum, so that we can write s is minimum. Okay, so ds square by dr, that is equal to, here 9v square is constant, so what is the derivative of 1 by r square? We know that minus 2 by r cube, that is derivative of 1 by x square is d by dx of 1 by x square is, so x raised to minus 2, right? So minus 2 into x raised to minus 3, that is minus 2 by x cube. Okay, so here similarly here derivative of 1 by r square with respect to r, that is minus 2 into, okay, minus 2 into 9v square divided by r cube. 9v square is constant, so 9v square into minus 2 by r cube. Okay, I will write in that form. So 9v square into minus 2 divided by r cube. Okay, plus here pi square is constant, so derivative of r raised to 4 is 4 pi square r cube. Okay, 4 r cube is the derivative of r raised to 4. Okay, then that is equal to minus 18v square divided by r cube plus 4 pi square r cube. Then here now we have to find the value of r, right? So when it is minimum, so what is the value of r? Okay, when it is minimum, the r is equal to 1. So here for that, let's take ds square dr, that is equal to 0. That implies it is equal to 0. It is equal to 0 implies 4 pi square r cube is equal to 18v square divided by r cube, right? This term is equal to 0 implies 4 pi square r cube. It will go to right side, so that is equal to 18v square by r cube. Okay, so that implies here take this r cube here left side, and that will be 4 pi square r raised to 6, that is equal to 18v square. Okay, that implies here 2 2s are 2 9s are. Okay, then r raised to 6 is equal to, take 2 pi square this side, so 9v square divided by 2 pi square. Okay, so what is r? R raised to 6 is this one, so r is equal to 9v square divided by 2 pi square whole raised to 1 by 6. Okay, that is 6th root. Okay, so r is equal to 9v square by 2 pi square raised to 1 by 6. Now here we have to prove the curved surface area is minimum, right? So for that we have to find the second derivative of this s square. Okay, so here let's find d square s square by dr square. Now let's find second derivative of s square, that is d square s square by dr square. Okay, because we have to prove the volume, that is curved surface area of the cone is minimum. Okay, that means we should get it is less than 0 at this point, that is r is equal to 9v square by 2 pi square whole raised to 1 by 6. Okay, now let's find second derivative of s square, that is differentiate it again with respect to r. So here minus 18v square is constant, so we have to find the derivative of 1 by r cube with respect to r, right? So derivative of 1 by r cube, d by dr of 1 by r cube, that is d by dr of r raised to minus 3, that is minus 3 into r raised to minus 3 minus 1, that is minus 3 into r raised to minus 4, that is minus 3 divided by r raised to 4. Okay, so here minus 3 divided by r raised to 4, so that minus minus become plus, so here we will get 18v square is constant, then minus 3 by r raised to 4, so minus become plus, so 3 divided by r raised to 4. Okay, then plus derivative of this one, 4 pi is constant, derivative of r cube is 3r square, so 3 into 4, 12 pi r square. Then see here, when we substitute r is equal to this value, that is r is equal to 9v square by 2 pi square whole raised to 1 by 6 in this, that is d square s square by dr square, obviously it will be positive, right? Because here volume is positive, and when we substitute pi is, we know that pi the value of pi, so here we have to substitute r is equal to this one, right? So when we substitute r is equal to this value, this d square s square by dr square is greater than 0, that is we can write d square s square by dr square greater than 0 when r is equal to 9v square by 2 pi square whole raised to 1 by 6. Okay, that means this surface area, that is curved surface area of the cone is, it is greater than 0, means is minimum. Okay, it is minimum when r is equal to this one. Okay, next what we have to prove? See, we have to prove altitude of the cone is equal to root 2 into radius of the base. Okay, base of the cone. So here we have to prove altitude of the cone, that is height, right? So what is h? Height is here, h is equal to 3v by pi r square. So here we will substitute r is equal to this one. Okay, so we have to prove h is equal to root 2 into r, right? So we have to find, see, let's find what is h by r. We should get root 2, then h is equal to root 2 into r. We have to prove h is equal to root 2 into r, right? So let's find h by r, h divided by r. So we should get root 2. Okay, now let's simplify. H divided by r, h is nothing but 3v divided by pi into r square. R is nothing but, see, we have to substitute r is equal to this one. Okay, so here because we have proved the surface area is minimum when r is equal to this one, right? So we have to substitute r is equal to 9v square divided by 2 pi square whole raised to, okay, it is, see, h is equal to this one. What is h by r? 3v by h pi r cube. Okay, one more step I have to write. See, h is equal to this one. So h by r is 3v divided by pi r cube, multiply r also. Okay, h is 3v by pi r square into r, that is 1 by r into 1 by r. So it will be 3v by pi r cube. Now let's substitute r cube. Okay, r is equal to, so 3v divided by pi, what is r? R is 9v square divided by 2 pi square whole raised to 1 by 6, that is r. So here r cube, right, that is whole raised to cube. See here, x raised to 1 by 6 whole raised to cube, that is nothing but x raised to 3 by 6, right? So here it will be 3 by 6 because r is whole raised to 1 by 6 and whole cube, that will be 3 by 6. Okay, so here it will be 3v divided by pi into, here 3 by 6 is nothing but 1 by 2, right? So 9v square divided by 2 pi square whole raised to 1 by 2. Whole raised to 1 by 2 means square root, right? So what is the square root of this one? 3v divided by, see, we know that 3v, 9v square is the square of 3v, right? So here its square root is 3v. Okay, 9v square. See, 9v square whole raised to 1 by 2 means square root of 9v square, square root of 9 3, square root of v square v, right? So 3v is the pi into 3v is the square root of 9v square. So 3v divided by, what about this one? Here we can write root 2 into pi, okay? Because square root of, see, square root of 2 pi square, square root of 2 root 2 into pi square, root of pi square is pi. So here root 2 pi, okay, because it is whole raised to 1 by 2 means square root, okay, square root of these terms, okay. So here see 3v cancelled, okay, and here pi cancelled, then it is the denominator of the denominator, it will come to numerator, right? So here it is equal to root 2. See, it is proved. H by R is equal to root 2. That means H is equal to, this implies H is equal to root 2 into R. That is, altitude of cone is equal to root 2 times the radius of the base. That is, H is equal to root 2 into R. Hence, it is proved. Look at the next question. Show that the semi-vertical angle of the cone of the maximum volume and of given slant height is tan inverse root 2. Okay. So here, see, we have to prove the semi-vertical angle. Okay, semi-vertical angle of the cone. See, this is the semi-vertical angle. Let alpha be the semi-vertical angle. And let h be the height of the cone and L be the slant height of the cone. R be the radius of the base of the cone. Okay. So here we have to prove that alpha is equal to tan inverse root 2 when the volume of the cone is maximum. Okay. When the volume of the cone is maximum, alpha is equal to tan inverse root 2. That we have to prove. Okay. So here, what is our function? Volume of the cone, right? So let's find. See, we have to write this one first. Let h be the height of the cone and r be the radius of the cone and L be the slant height and alpha be the semi-vertical angle of the cone. Okay. So here, what is the volume of the? It is given slant height. So given slant height, it is given. That means slant height is constant. Okay, L is constant. So V is equal to 1 by 3 pi r square h is the volume of the cone. That is the formula for the volume of the cone. Okay, so here what is r square? See, we know that L square is equal to h square plus r square by Pythagoras theorem. Since it is a right angle triangle, by this figure we can write L square is equal to h square plus r square. Okay, so what is r square? R square is equal to L square minus h square. Let's substitute here. So 1 by 3 pi L square minus h square into h. Okay, then that is equal to 1 by 3 pi L square into h minus 1 by 3 pi h cube. Okay, so it is our V. Then here we have to prove that is d square V by d h square with respect to h. Okay, d square V by, it is, here L is constant. Okay, so d square V by dh square maximum is less than 0 at which value of h. Okay, that we have to find. So as usual we will find dv by dh. Okay, dv by dh. What is dv by dh? Differentiate it with respect to h. So 1 by 3 pi L square, that is constant, into derivative of h with respect to h is 1. So minus 1 by 3 pi is constant into 3h square. Okay, that is equal to 1 by 3 pi L square minus, here 3 cancelled. So pi h square. Okay, then so here let's find the value of h. That for that dv by dh is equal to 0 implies 1 by 3 dv by dh is equal to 0 implies 1 by 3 pi L square minus pi h square is equal to 0. That implies pi h square is equal to 1 by 3 pi L square. Okay. That implies h square is equal to, see here pi cancelled, right? Yes, pi cancelled. Then h square is equal to L square divided by 3. Okay. That implies h is equal to L by root 3. L by root 3. So here we have what h is equal to L by root 3. Now what we have to prove? We have to prove volume of this cone is maximum, right? So volume of the cone is maximum means volume of the cone is greater than 0. That means d square s by d square v by dh square are less than 0 when h is equal to h by root 3. For that, let's find second derivative, that is d square v by dh square. Okay, here we have to show it is less than 0. Okay, so here what is our dv by dh? This one, right? So let's differentiate it again with respect to h. So 1 by 3, it is constant, right? So it is constant. So derivative of constant is 0. Then minus pi constant. So h square 2h. Okay, so minus 2h. See here, h is nothing but height of the cone. Okay, so height of the cone is negative, is not possible, right? So here h is always positive. And if we substitute, see our h is equal to L by root 3, L is constant, right? Because it is the slant height of the cone, it is always positive. So when we substitute h is equal to L by root 3 here, we will get minus 2 into a positive value, right? Minus 2 into a positive quantity, that is minus, right? Always minus. So it is less than 0. Okay, here we will write d square v by dh square is less than 0 when h is equal to L divided by root 3. Okay, L by root 3. Then, so after that, okay, we have proved the volume of the cone is maximum when h is equal to L by root 3. See what we have to prove? We have to prove semi-vertical angle of the cone, that is equal to tan inverse root 2. See here, what is the semi-vertical angle? This alpha, right? See here, from this figure we can write, see, tan alpha is equal to opposite divided by adjacent, right? That is r divided by h. Okay, so what is alpha? Alpha is equal to tan inverse of r divided by h. Okay, so here we have to prove, see, we have to prove alpha is equal to tan inverse root 2, right? So alpha is equal to tan inverse root 2 means we have to prove r by h is equal to root 2. Okay, now we have to prove r by h is equal to root 2. So let's find r by h. So what is r? What is our r? R is nothing but, see, r square is equal to L square minus h square. So r is root of L square minus h square divided by h. Okay, that is equal to r by h is equal to square root of L square minus h square divided by h. Okay. So here let's remove this square root. So square on both sides. So r square by h square is equal to L square minus h square divided by h square. That is L square by h square minus 1. Okay. So here what is our L? See, L is nothing but, see, from here we know that h is equal to L by root 3. The volume is maximum when h is equal to L by root 3. So from here L is equal to root 3h. Substitute here. So that implies, so r square by h square is equal to, that is h square, 3h square. Okay, L is root 3h. So L square is 3h square divided by h square minus 1. Okay, that is here h square cancelled. So 3 minus 1 is 2. So r square by h square is 2. So that implies r by h is root 2. Not minus root 2, only plus root 2. Because r is positive, h is positive, right? Because r is the radius, h is the height of the cone. It is always positive. Therefore r by h is root 2. So what is r by h? That is r by h is, see, alpha is equal to tan alpha, right? R by h is equal to tan alpha. That implies alpha is equal to tan inverse root 2. Okay. Therefore, see, tan alpha is equal to root 2. That implies alpha is equal to tan inverse root 2. Okay. Hence it is proved.